All right, so find the volume of this. I'm looking at this problem. What's the first thing that you should do? Yeah, switch this over to Kelvin.
Yep.
What kind of problem is this? How do you know it's an ideal gas law problem? There's no before and after. There's no P1, V1, right? Or P1, P2 kind of stuff. This is just a bunch of individual pieces of information with no alternative to it. I'm looking for a volume. Is there any volume unit up here?
No.
No, so what do you use? The ideal gas law constant, the R. So 0.08206 liter atmospheres mole Kelvin. And so then I'm going to throw 4.4 mole here. And then I'm going to put 317K here. And then I'm going to put 5.60 ATM here. And then when I do that, I get my kelvins to cancel, my moles to cancel, my ATMs to cancel. The only unit I have left is liters there. So I'm going to end up with something in liters. So what do we got? 0.08206 times 4.4 times 317 divided by 5.6. I get 20.4 liters. Okay. Want to find the volume, another volume question here. So I've got grams, I need a volume unit, I've got ATMs, and I've got temperature. So same kind of problem, just a little bit different. What's up?
For ideal gas law, wouldn't it just be a lot easier just to plug it in? PV equals nRT.
I did.
Yeah, but like.
Stop fighting it.
I know, but for this one specifically.
No, it's not easier. It just isn't easier.
Multiplying across.
Let me see what you wrote down, and then tell me if I want to know if the units look good.
Yeah.
The units look great?
They're solid.
They're solid?
Yeah.
What do you think? Do you think his units are going to be
Oh,
solid?
guys.
No, I don't.
I guess so.
That's not this homework.
Yes.
No, your units are not right.
Yeah.
You wrote R for the units for R.
No.
Yeah, what do you mean no? That's a capital R right
I put it
there.
in there. Well, because my calculations, I know.
R stands for liters.
But it's also 0.08206.
Right?
So
You didn't
when I
manage
put-
the units.
When I put R,
You did manage the units.
my units all canceled. So I did that.
You
And I
you
knew that I
think
was going for volume.
you think they
But
cancel?
you didn't even put liters in the problem. You said find volume.
What is this thing right here?
Okay. If you do it the right way, I wouldn't have liters times atmospheres over moles.
Oh my goodness.
What?
I'm not
There's
gonna
no
win,
good
but
out
I'm
for you
gonna
here,
go around.
okay? So no.
I was thinking about it today. The algebra is easier for me than
So like blood these together. Divide out.
But again, there are a million questions with no equation. So what do you do?
Well, in that case, you could railroad test.
So just do it all the time. Then you don't have to even look up the equation.
What if you memorize?
Oops. Okay, what do we got here? 292K, and then I've got 2.12 ATM. And I don't have any moles, but I've got this 64 grams of SO2. And then it's pretty close to 64, isn't it? 15.9994 times 2 plus 32.
64.5. Okay. It was like 0.49.
What is it? 32. 0.49.
Yeah, it is.
So we've got 3 sig figs here, so I can go 64.06 grams SO2, 1 mole SO2. And so then when I do that, my K cancels, my ATMs cancel, my moles cancel, my grams cancel. And I've got 0.08206 times 292 divided to 12 times 64 divided by that 0.113 liters. Okay. What provides pressure inside of a container?
I gotta look.
Particles. Impacts, right? So if I've got 2 different gases in there, how could one gas be providing more pressure than the other gas? There's more of them, that's it. There's just more of them. So what I need to know is how many particles I've got. If I know how many particles I've got, then I know that the fraction of the pressure that that thing is providing. So I've got 56 grams of N2. Yep, 14.0. So 28.01 grams of N2, 1 mole N2, so 56 divided by that thing. I get 2. 12 grams of helium. And this is 4.00, what is it? 26? And then with sig figs, it works out to be 3 mole. Okay, so I know right here, this guy is providing 4 ATM of pressure. So how much must this be providing? That's the question, right? Okay, so this is just, I don't know, what would that be, like 4th grade cross multiplication, right? So what I know that 2 moles of N2, let me do it the other way around, that way I get a nice pressure unit. So let's do 4 ATM. 4 ATM of pressure is equal to 2 moles of N2. And I've got 3 moles of helium. And so I don't know what the pressure of the helium is. But it's going to be 6 in this case. So 4 divided by 2 times 3 gives us 6. So I have X equals 6 ATM. So then the pressure total is going to be 10 ATM. What kind of relationship do volume and pressure have in Boyle's law? Volume increases, pressure decreases. Great. What's the name of that relationship? Inverse. Draw what? Yeah, so whatever one does, the other one has to do the opposite. That's what we mean by inverse. So energy level diagram for bromine. So what do we need? What information do I need for this? What do I need off the periodic table? No, I mean that's a good verification. I know the atomic number, so which is just what? What? 35. So that means I'm managing 35 electrons. Okay, so How do I know this order?
You have a triangle things.
That's a way. That's not. That's definitely not my favorite way.
Yeah, not mine either. It is great. This one. Oh, I think it turned it in.
Let's open this in
Draw from my
Paint.
Oh,
It's gonna be right.
Okay, so what I need to do is fill from the sublevels that are closest to the nucleus and then work my way away from the nucleus. So what's the closest sublevel to the nucleus? 1s. How do I know that? Say again. So how do I know that what I just circled here, how do I know that's my 1s? That's the first energy level, right? First row. Okay, so first row, and then there's only 2 there, so it's the s. So I can put 2 electrons in that. So now what do? Here's my next one, right? So what's this? 2s. Okay, I know that because I'm in the s block, and I'm in the second row. We okay with that? So what's this one right here? How do I know that that's 2p? I'm in the p block, so it's definitely a p, and it's in the second row. That's the order so far. So now I move on. I'm filled up with that. This is the next thing I hit. Well, what is this? 3s. This is the next thing that I hit. What's this? 3p. This is the next thing I hit. What's that? 4s. I did not hit the 3d. The next thing I hit in order was my 4s. So that's where I put my next 2 electrons. This thing is what kind of block, or what kind of block here? Say again? It's a D block. Okay, so this is a D for sure. I know that. Which D is it? How come it's 3? It's in the 4th row. How come it's 3 though? What is the first D available? 3D. There isn't a 1D, there isn't a 2D. The very first one is a 3D. So before I put any electrons in any d orbitals, I put electrons in the 3D, because that's the first of the Ds. Okay with that? So this is the first d orbitals we hit. So which d orbitals must it be? 3D, even though I'm in the 4th row.
Gotcha.
So what about this guy over here? 4p. Okay, so I'm going to put, let's switch to a different color. I'm going to put 2 electrons in this one, right? Then I'm going to put 2 electrons here. How many am I going to put here? 6, 2, 6, 2. How about here? 10. And then this one? 5, because I run out of electrons. Once I've hit zinc, I'm at 30 electrons, and I've only got 5 more electrons to deal with. Okay, so then if I go back over to this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. And then I'm done.